as well. We're starting, so reviewing the assessments. So what do you reckon? Question 3?
Yeah.
So question 3 is b to the power of a half, okay, times b to the power of 3 over 2, all divided by b. Okay. So first step was simplify the numerator, simplify the top. So when you multiply with the same base, what do you do with the exponents? Add them. Okay, so I'm going to add those two together, and I get b to the power of 4 over 2. It's 1 half plus 3 halves is 4 over 2, which is b squared. That is all divided by b. So b squared divided by b is b. Yeah?
I did that, and
Yeah.
then you wrote simplify further.
Did you have just b as your answer?
I put b squared over b equals b.
Oh, let me check that. Maybe I didn't spot it. Right. Okay, that's question 3. Well, actually, if you feel you've got what I've written up there, then you can mark on your paper that you do have that. That can go towards it as well.
Something wrong with the like radical form.
In what way? Why would you want radical form?
I'm not sure.
Because if you did, well, b to the power of a half is the square root of b times b cubed square root, or is it b square root cubed? Okay. And actually, if we do that, square root of b times the square root of b cubed would be the square root of b to the power of 4 over b. So that's square root of b times the square root of b times the square root of b times the square root of b all over b. And actually all of this does simplify to b times b, so b squared. So we could do that. You can use radical form and get to the same point. Because actually, radical form, exponent form, different forms of the same thing, right? As long as you get to that answer b.
Yeah, I got to the root b times like to the power of 4.
Well, I did that exact thing, except I thought I wrote the 3 in that thing as like just not an exponent.
Yeah, you did it as a 3 times, which is big wrong, isn't it? Yeah.
Would I get any points though for b?
Well, like I said, we're not looking at points. You're showing some level of understanding there, aren't you? So if I look at it and see, yeah, she used this method, would it be considered an appropriate method when we're already in exponent form and it can be nicely simplified anyway?
Possibly.
Possibly not, but yeah, that's something to consider. That's when you're giving yourself a grade, that's something to take into consideration. It's different for me, this criterion marking, rather than just giving out marks. Because yes, if it was, let's say there were 3 marks for that question, I would have given you a method mark for that. Yeah? Because any method is correct, but you'd have lost marks because you didn't carry on the process. Yeah.
I thought I did well on this, but I didn't, and it's just me. I'm 7.
Okay, so we were asked for 6 first, were we? 6 and then 7?
Number 5, not 6.
5, sorry, not 6. Let's go in order. So number 5 was a to the power of a half multiplied by a plus 1 over a. Okay, so expanding brackets. So when we multiply them together, same base, we add the powers. So I've got a to the power of 3 over 2 plus, well, if I like, I can change that to a to the minus 1. So then a half plus minus 1 is a to the minus a half, which is fine. I'd be perfectly happy if you did it. The question, however, is in this format, so we might say, actually, I want to give it as that. But that's fine. I don't need to do anything else. All right? I'm not asked for it in any particular form. I could have done, you could rewrite it in radical form, surd form if you wanted to, but you weren't asked for that. So that's it. Just simply expanding brackets. Okay, so question 7, we've got 4 cubed to the power of minus 2 multiplied by 4 squared squared. So this is just checking your knowledge of. We just multiply those because it's a power to a power. So we've got 4 to the power of minus 6 times 4 to the power of 4. Which if you then add the powers, because we multiply like that, you end up with 4 to the minus 2, which is 1 over 16.
My issue was at the start, like at the very first, I forgot, like instead of multiplying indices of the same base, adding indices of the same base if they're being multiplied, I just added them just added them, like for no reason.
Yeah, I think.
And that's how I got 4,096.
You got that too?
Yeah.
No, I got 36,506.
Question 8, guys. Stay focused. Question 8. There was a little bit to this. This wasn't not hard. Definitely not hard, which is why I didn't give it a 7 to 8 level. But definitely tests how much you can read the question and how much you pay attention. Because it's this bit here, the fact that it's all squared, okay, that we have to pay attention to. And I think that caught, well actually the first time I went through doing the solutions, it caught me out and I went back and went, well, no, I've missed that. So we take it step by step. Order of operations, BODMAS. We do it inside the brackets first. So the first thing I think we got wrong is to say we do that and we have to apply it there as well. So we end up with 2 to the power of 4, p to the power of negative 16. A lot of people got that p to negative 16, but they didn't have the 2 to the power of 4, which is 16. P to the negative 16. So that's that first bit done. All right. I can remove those brackets now. Got that out. These brackets are still there, but now I can deal with inside the second set of brackets. Okay. Which ends up being 16 times 3 is
48.
p to the power of, okay, all of that finally is squared, so we have 48 squared, p to the minus 28. So the only thing we have to do, and to be honest, I would hope that you would be able to do 48 squared. I didn't actually do it this way myself, I ended up with a different way, but 48 squared, so you could manage in a test to do 48 times 48. 8 times 8 is 64, 4 times 8 is 32, that's 38. Okay. 0, 32, 16, so 18, so 4, 8, 12. 2204 was it?
Wait, 8?
Am I right?
I missed out on the 0, but everything else.
I think it was a 19.
I seriously forgot a 1 and 16. But that threw off my whole
Can you just check me that? Is 48 squared 2024?
I think it's, yeah, Yeah, I think it's
It's
19.
2,304.
I thought it was 2,304. Where did I make a mistake?
The 18, it's actually meant to be a 19.
That's supposed to be a 90.
Because 4 times 4 is 16, then add 3.
There you go. That's where I made my mistake.
I think I should get a higher grade for
But if, to be honest, if you left it as 48 squared, at least you've shown knowledge and understanding. It might not be completely simplified, but you knew what you're doing. If you just made that decision to go 48 squared, I'm not allowed a calculator, I'm not going to do that, fine. That's not an issue. But not many people even got to the e to the minus 28. Okay? Are you all clear now about how that one works? Yeah? You see, it's not actually that difficult, you just have to follow it step by step. What was the next one you wanted to do? 9 tended to be fine. Okay,
Oh, can we do 10?
Yeah,
I know it's a little easy, but I got it.
I got it wrong most of them.
yeah, so we've got 5 to the power, 5 fourth root of 5 to the power of 5. So first of all, we leave that power alone and change that to 5 to the power of a quarter.
Oh.
That's
And then you just multiply those and we get 5 to the power of 5 over 4. And it asks for it in exponential form.
Okay. I just
wrote a 5.
I just put the 4 outside and then took off the square because I know that whatever the number at the bottom is what type of root you're trying to find. So like something to 1 over 2, you're finding the
Square root.
square root of it. So then I just took the 4 and put it there below, and then took off the
Yeah.
radical sign. That was it.
Wait, I was right. I just
Ah.
didn't keep going.
Oh yeah, you were.
Okay. So let's have a look at the one I do want to go through is question 12. Because several people, even though they kind of knew, did make a fundamental error, which is this.
Oh yes.
I'm so close to that.
The problem with this is people, you can tell me, the ones that kind of got closest wrote 3k to the power of a half to the power of 5, and there's a mistake in that.
Wait.
I was first
Since not many people got it right, could we change that to a 70? I didn't get it right.
No, it's
but
not. Just because you didn't get it right doesn't mean it's harder.
Yeah.
It just means you didn't study that. You there's a gap in your knowledge that you're sorting out. What's the issue with what I've just written? Told you, so. Greg?
It's already, I don't know, I got the right, I can't explain it. I don't know.
Cares?
You need to put brackets around 3k.
Yeah.
That's why
You will notice that the root is around the whole 3k. Therefore, the power has to apply to the whole of the 3k. Therefore, you either do 3 to the power of a half, k to the power of a half, or we have to put in the brackets. That's then the issue, because then we have 1 over 3k to the power of 5 over 2, which then becomes 3k to the negative 5 over 2, but there must be brackets.
I forgot the brackets.
And that's it, so the majority of your knowledge is there, but the real important thing that makes it what it is not there. Okay? That is an incorrect, without the brackets it means something completely different. Okay? That was a big one. What is there one you want to go through?
I guess 14 is just 10.
14 is just 10, yeah.
Yep.
So.
Yeah, I got that wrong.
Oh
I literally, I did.
I think even that was just quite obvious.
Yeah.
I was contemplating, do I make that a 1, 2, or a 3, 4? Well, it's still a bit knowledge.
We did 15.
15, yeah, I did think 15. So 64. Now again, this is the same problem that you've attributed before, is why I wanted to go to, because a lot of you have obviously a gap in the knowledge and you've done it multiple times. That's why I know it's not like a silly mistake, so you don't have. Again, I think you've got it's n to the power of -2, because you do 12 times 6 is -2, which is fine. But too many people left it as 64.
Yeah.
64 is incorrect. Okay, it needs to be 64 to the power of -1/6 as well. Okay.
Oh.
Yeah, I just.
Now, if I write that as 1/64 to the power of 6 n squared, then that moves on to, well, I've got the 1 over the n squared bit, I just need to know 64. So 64 to the power of a 6 is the same as the 6th root of 64. And that's quite obvious because the only thing you're going to be asked to do without a calculator, the answer is going to be 2. So it ends up as 1 over 2n squared.
Oh, I messed up.
Can we take a look at
I forgot to put the 1. And then I forgot that we shouldn't have put this when I go.
And 17.
So 16 was fine. 17.
Oh no, it's I understand.
Can we do 20?
17 was generally okay, but some people ended up with a final answer. So let's just say 72 over root 3 ended up as 6 root 6 over 3,
Yep, that's
which is, it's a correct interpretation, but it's not simplified enough. We've got 6 root 6's divided by 3 gives me 2 root 6's. Okay? The 6 divided by the 3 needs to be dealt with. Alright? So that was the common one that people just forgot to do. So again, it's not that you got something wrong, you just didn't complete something. 18. Not too many people managed to finish that off. When you are adding radicals, you are looking to put them in the same base. Okay? So we've got 16 times 2, so that's 4 root 2's, plus root 4 times 2 is 2 root 2's, becomes 6 root 2's.
I didn't even know you could do that to 8. I just left 8. Oh,
Yeah, I
got
see.
it.
Same. I knew you could do that, but
Well, it's kind of, you know it's going to have to happen. If you're being asked to simplify, the plus has to go somewhere, you know. So 19 was easy, I think. We got that because we did the function notation. So 20. Now I am a little bit surprised at 20 because Kieran was explaining this to Zoe literally minutes before the test and then didn't do it.
I put minus instead of plus.
So we've got 1 plus root 5 over 3 minus root 5. And when you see a denominator that needs to be rationalised with 2 parts, you know it has to be difference of 2 squares. So I'm going to have to write
Plus
3 plus root 5. Therefore, yeah, that's the thing. Remember we had that discussion that if I just multiply by root 5, I don't get rid of a root 5. Yeah, because I would get rid of that one, but it would end up on that.
But then you can simplify that 1 by timing.
So if you have 1 plus root 5 over 3 minus root 5 and you multiply by, if you're going to multiply, there has to be brackets. If you do that, what do you end up with? You end up with root 5 plus 5 over 3 root. Hang on. What's on the bottom, sorry?
3 root 5.
3 root 5
Minus 5.
minus 5. So I'm actually no better off than where I started. The root 5's just changed position.
Yeah, I just got rid of the 5.
Yeah, you can't then just cancel them because you could have just done that then. So that method, big, doesn't work for us. Oh, that's right, you can write it as that's incorrect. Do not do this. That's just important to know. Do not do this. So when we expand this, remember, the denominator then ends up as, using the difference of two squares, okay? We can then, we're in this form, we can write it like this, so we end up with 3 squared minus root 5 squared, giving me 9 minus 5, which equals 4. Okay? So we should have a denominator of 4. If I expand on top, I get 1 times 3 is 3, plus 3 root 5, plus another root 5, plus 5, so I end up with 8 plus 4 root 5. Now you'll notice that if you have 8 plus 4 root 5, you can now divide that by 4 and end up with just 2 plus root 5. Because now I can, because I've got a factor of 4 in both terms on top, I can divide by the 4. Okay. I'm left with 2 plus root 5. Okay?